ഹലോ അശ്വതി.
ഹലോ മിസ്. ഹലോ.
കേൾക്കാമോ?
കേക്കാം മിസ്.
ഇത് മധു സാറിന്റെ അവറാണ്. സാർ ഇപ്പോൾ ജോയിൻ ചെയ്യും, വെയിറ്റ് ചെയ്താൽ മതി.
ഓക്കെ മിസ്. ഓക്കെ.
Hello, please wait, okay? Madhu sir will join soon. He's having some net issues. Okay. Okay, thank you.
Okay, Mr. Ranjit sir.
Okay, sir. Okay.
Okay. Okay. Okay. In the previous class, we discussed. Okay. 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 In the previous class, we discussed about this topic. Okay, translation of original sentence into an internal representation of its meaning. So basically, there are three stages involved in it. Okay, there are three stages involved in it. Which are the different stages? The first stage is parsing. Okay, the first stage is parsing. The first stage is parsing. Okay, so what is parsing means? Parsing or syntax analysis. Okay, so and basically you know what is parsing or syntax analysis. Okay, so uh, it will create a syntax tree. Okay, in the compiler design subject you studied about syntax tree. Okay, so if an input is given to the syntax analyzer, it will apply some grammar rules and create a syntax tree. Okay, that is about the parsing. And after the parsing step, what we will do? We will do semantic analysis. Okay, so the first stage is parsing and the second stage is semantic analysis. Okay, so this is parsing, and the parsing, the parser will do parsing. Okay, so it's about the parsing, and the parser will do the parsing at first. Okay, then we will do the next stage is semantic analysis. Okay, in the previous class we discussed this topic. So next is semantic interpretation. Semantic interpretation, which produces a representation of meaning of the text. Cannot hear. Which produces a representation of meaning of the text. The text we are analyzing. We are analyzing one text. The semantic interpretation produces a representation of the meaning of the text. It will find the meaning and represent it in by using somewhere. Means you can use conceptual graph, conceptual dependency, or semantic network, etc. We can use for representation. So next we are going to the third step. Okay, third step, what we will do? We will add global knowledge. Okay, we will add global knowledge to the internal representation of text. So in the third stage structure, structures from the knowledge base are added to the internal representation of the sentence to produce an expanded representation. Of the sentence. So what we are doing is that in the third stage, okay, we will add some more knowledge, which is the global knowledge, to the internal representation, and this is called the expanded representation. Okay, this is the expanded representation. So this is about the third stage. This adds the necessary world knowledge required for complete understanding of the text. Okay, so these are the three stages in the conversion, and next we want to discuss with an example. Okay, hello, Ashwadi, okay ano? Ashwadi, okay, connection ഉണ്ടല്ലോ?
Sir,
ഒന്ന് റെസ്പോണ്ട് ചെയ്യട്ടെ,
ഉണ്ട്
കുറച്ച് കണക്ഷൻ പ്രോബ്ലം ഉണ്ട്. Okay, so this is input we are giving. Okay, we will give this input to the parser and it will produce a syntax tree. It will produce a syntax tree, and this syntax tree consists of leaf nodes and internal node. Internal node are the syntactic components. For example, verb phrase, noun phrase, etc. etc. Okay, these are basically the in terms of compiler design, it will be the variables. Okay, there will be a production. Production consists of variables and constant. This internal node represents the variables. Okay, so the last leaf node is basically the values. Okay, the input we are applying. So here Tarzan, then Kissed, Jena. These three are uh, tokens, basic tokens. Okay, so Tarzan kissed Jane. So this is the input Tarzan kissed Jane, and it will convert this into a syntax tree. Okay, then it will give it to the semantic interpretation module. Okay, so what is semantic interpretation? So what is semantic interpretation means? It will create a, it will understand the meaning of the sentence and represent it in a internal representation. You can note here we are using which type of internal representation? It is semantic network we are using. Okay, the same sentence we will express in the internal representation. We can use semantic network or conceptual graph. Okay, it's also similar to the semantic network. Just try to understand the process. Okay, so next what we will do, next step is we will apply this local internal representations to the next level, third stage. In the third stage, what we will do, we will expand this knowledge by adding general knowledge about the world. Okay, so this is just an example. Here, this is the expanded representation format. Okay, expanded representation format. Here with this is our local representation. To that we will add external knowledge. Then this will be the expanded representation. Okay, so these are the third stages. These are the three stages in the process. So the topic is translation of original sentence into an internal representation of its meaning. So how it can be done? There are three stages. One is parsing, another is semantic analysis, third is expanded processing. Okay, so just to go through this example and write. Okay, so this is about this topic. Next we want to go to the syntax. Okay, we are going to the section syntax. Okay, basically you know what is the, every language should have a syntax. Okay, so syntax rules define the structure of a sentence. Okay, so basically syntax rules defines the structure of a sentence. That is about the syntax rules or syntax. How can specify the syntax rule? So there are two issues. One is how can specify the syntax rules, and how can, second issue is how can parse a sentence. Okay, so to specify the syntax rule, every language has its own grammar or syntax. How can specify is we can use context-free grammar, CFG. Okay, you already studied in the previous sems. Then next is how can, this is about the specification of syntax rules. Then how can parse a sentence? How can parse a sentence? We can use top-down and bottom-up parsing. Okay, we can use top-down and bottom-up parsing methods. You can use top-down and bottom-up parsing method. In the compiler design, you studied about various parsers. Okay, for example, recursive descent parser, then shift reduce parser, operator precedence parser. There are different parsers. We can use any of them. LALR parser, CLR parser, etc. We can use any of them. Okay, Okay, so Amrita, is it okay? Okay, please respond, Ashadi. Okay.
Sir,
So
okay.
using, so another is using dynamic programming concept. Okay, there is another method of parsing which is using the dynamic programming concept. Dynamic programming concept, that is called memoization and dotted pair. This method is called memoization and dotted pair method. So in the previous compiler designs, you studied about different parsers. Okay. Additionally, we can use dynamic programming concept-based parser, which is called, this type of parser is called memoization and dotted pair parsers, or it is called early parser. Okay, early parser. So that we want to discuss in the next session. Okay, you can note here early parser. Early parser. Okay, this is a very important topic. In the university exam, they asked this questions. Okay, so there are different methods. One is top-down and bottom-up parsing. Another is dynamic programming concept-based parser. Then that is called the memoization and dot pair concept is used. So that are called early parser. Okay, so we want to study how an early parser will work in the next class. Sorry, in the next sections. So in the first approach, we are using a context-free grammar. Then what basically we will do, we will create a parse tree by applying we will apply different rules using bottom-up or top-down approach. Then we will create a syntax tree. Okay, that is our approach. That is our approach. Okay, so the first method is using context-free grammar for the grammar rule representation and use bottom-up or top-down parsing. Okay, so consider the below grammar. For example, we want to consider this grammar. Okay, there are 11 grammar rules are given. 1, 2, 3, 4, 5, 6, 7, up to 11 rules are there. Okay, there are 11 productions are there, or grammar rules are there. Okay, from that, what we want to do, we want to derive a string, the man likes the dog. Okay, so in the exams, usually one type of question will come in this way. They will give productions. Okay, lot of productions will give. Then a string will be given. For example, the man likes the dog. Okay, so the man likes the dog is the string. You want to create the parse tree. Okay, you want to show the parse tree. So in the compiler design subject, we studied how can create a parse tree. The same method here we want to apply. The same method. Okay, so there is a string, there is a set of grammars. We want to create a parse tree. Okay, we want to create a parse tree from it. Okay, so there exist two type of parsing, top down and bottom up. In top down, what we will do, start from the root symbol of grammar and try to derive the sentence. Okay, in the top down, what we will do, we will start from the root symbol. Here sentence is the root symbol. Then we will replace the sentence with some other production. In that way, we will replace the symbols until we get or we derive the entire string. This is called top-down parsing. Okay, so try to understand what is top-down parsing. We will start from the root, then replace the symbols using the corresponding production. Then we will try to derive the string in a top to bottom fashion. Okay, this is called a top down approach. Okay, so that is about the top down approach. Then what is bottom up approach? What is bottom up means? Starting from the sentence, try to reach at a root. Okay, so through reductions. Okay, we will start from the sentence itself. Okay, we will start from the sentence components. Okay, the man bites the dog. Then what we will do? We will apply reduction. Okay, we will apply reduction. Okay, so this is a bottom up approach. In that case, what we will do? We will apply reductions. Okay, reduction. We will apply reductions. Then we will try to reach at the root. If we can reach at the root, then the parsing is successful. Else parsing is not successful. This type of approach is called bottom up approach. Okay, so this is called the bottom up approach. Bottom to top we will try to derive a string. So that is called the bottom up approach. Which are the different bottom up parsers? The most important parser is LALR. This is the one of the most efficient bottom up parser. This is you studied in your compiler design subject. Okay, similarly CLR, there are different parsers exist. Okay, so just I revise that. Okay, this is about the bottom up parsing. Okay, so here what we want to do is that the question will be like this. Okay, please respond, Ashadi. Okay. The man likes
Hello,
the
sir.
dog. Okay, okay, okay. So
Sir, okay.
okay. So the man likes the dog. Okay, so this is the sentence. From this sentence, for this sentence, I want to derive the parse tree. Okay. Also, so the method is we are using top-down approach. Okay, we are using top-down approach. Then what we will do? We will start from the sentence. This is the root symbol. Okay, here you can note this is the sentence. Okay, then what we will do? We will apply the production. There is only one production is there. Okay, in the right hand side, only one production is there, which is noun, phrase, verb, phrase. Okay, sorry, this is basically not here. Noun phrase is a variable. Noun phrase is a variable. Verb phrase is another variable. This is like these are non-terminals. For example, A and B, like this. Okay. So we have only one option here. We can replace the sentence with the noun phrase. We can replace the sentence with the noun phrase, verb phrase. Okay. So the tree will be like this. Okay. That is, we are replacing the sentence with these two terms. So the tree will be like this. Okay. Then what we will do next? So we created a tree like this. Okay. That is, we applied this one. Okay, we replaced the sentence with this right hand side of the sentence. Okay, now we want to focus on this. Okay, so noun phrase is there, verb phrase is there. So next, what we want to do? We will try to replace noun phrase. We can replace noun phrase with these two. Okay, this one is there, this one is there. Okay, we will try to replace here we used article noun. Okay, article noun. So what is the article? Here the is the article. So we want to derive a string starting from the. Okay, so the is an article. So we should use this production here. Okay, if we applied noun, then the sentence will always start with a noun. The will not be included. So in order to include the article, we should use this symbol. this production article noun. We should replace noun phrase with the article and noun. So this is applied. Okay. Then what we will do? Similarly, we can replace here before. Okay, I'm going in this path. Now what I will do? I will replace article with the symbol. The is an article which is matched with our sentence. Okay. Then noun is replaced with man. Okay. This is also matched. Okay. Next what we will do? So this is completed. Then verb phrase. What we will do? We need likes. Likes is a verb. Okay. Likes is a verb in the sentence. So next we need likes at the bottom. Okay. So what we will do? Verb phrase is there. So there are two options. This one is there. This one is there. Which we will apply? Which we will apply here. This I applied. Verb noun phrase. Okay. Verb noun phrase. This I applied. So then what we will do? Verb is replaced with its corresponding bytes. Bytes is the, sorry, this is not likes. This is actually bytes. Okay. Sorry, this is not likes. Okay. The man bites the dog. Oh, sorry. This is actually likes. The man never bite the dog. Okay. The man likes the dog. So the man, this is actually likes. Okay. This is in the text also bites is given. So this is likes. Okay. The man likes the dog. Never the man bite a dog. Okay. So this is about this change. Okay. Anyway, we will replace the verb with the corresponding verb in the sentence. It is likes. Okay. It is likes. Then what we will do? Likes. Okay. So then this is also matched. Okay. Next, this is expanded. Noun phrase is expanded. We want to derive the dog. Okay. We want to derive the dog. So there should be an article first. So article noun. Okay. Article noun is applied. Then the dog is derived. Okay. So this in this way we will create a parse tree. Okay. So this is about the top-down approach. Similarly, there is a bottom-up approach. What we will do? We will start from the string and try to reach us at the root. Okay. Anyway, here we are focusing on one method only. You can apply any method, you will get the same syntax tree. Okay. If you apply the top-down approach or bottom-up approach, you will get the same syntax tree. Okay. So also you know about the ambiguity. What is meant by ambiguity? If there are more than one derivation for a single string or more than one derivation for a sentence, then it is called the ambiguity. Okay. So we don't want, sometimes in the exam they may ask the question like this. Okay. What is meant by ambiguity? Because it is related to the syntax processing. Okay. So anyway, this is the concept we want to study. We don't want to study very deeper concepts. We want to just study what is how we can derive a string using either top-down approach or bottom-up approach. Okay. So we can this is the method we graphically we done this. So we can do this way. Okay. Sentence is there, then rule 1 is applied, rule 3, rule 7. In this order we are applying. Okay. Okay. In this order applying, I just used this and explained how this tree can be derived. Okay. I think that will be okay. You can use any idea. Okay. Anyway, and this is about this topic. So So this is about the using context-free grammar and top-down or bottom-up parsing. Okay, one question will be there in the university exams. So next is using dynamic programming concept. That is our second approach. Okay, so what we will do, it is called the early parser. Okay, this is called the early parser. Okay, so okay, anyway, please give your attendance in the chat box now. Okay, please give your attendance in the chat box starting from Abhilash. Okay, okay. Okay, so the early parser, this is the next concept, or this is the next type of parser that uses dynamic programming approach. It uses dynamic programming approach. So first point is, it is possible to implement parsing concept using dynamic programming approach. Okay, that is what is dynamic programming approaches. That is, when addressing a complex problem that can be broken down into multiple subproblem, save partial solution. Cannot hear save partial solutions as they are generated, so that they can be reused. So that is, when addressing a complex problem that can be broken into multiple subproblem, save the partial solutions as they are generated, so that they can reused later in the solution process of a full problem. This approach is called dynamic programming approach. Okay, so we will divide a complex problem into multiple sub problem. At the same time, what we will do, we will save the partial solutions. Okay, then these partial solutions are reused later to get the final solution. This save and reuse of partial solution is called memoization. This is another term. What is memoization means? This save and reuse of partial solution. This save and reuse of partial solutions is called memoization. Okay, so what is memoization? The save and reuse of partial solution is called memoization, the term. Okay, so what is early parser? This is about the dynamic programming approach. So early parser is a parser which uses the dynamic programming approach. So the early parser, in parsing with the Early's algorithm, the memoization of partial solution is done with a data structure called a chart. Okay, chart. So early parsing algorithm uses memoization because it uses dynamic programming approach. The memoization concept is implemented using a data structure called a chart. So this type of parsing is called chart parsing. Okay, early parser, also called chart parsing. Okay, chart parsing. The chart is generated through the use of dotted grammar symbols, dotted grammar rules. Okay, how can create the chart? Okay, or how can create the partial solution? We can use dotted grammar rules. Okay, so what is a dotted grammar rule? Okay, this indicate the state of parsing at any given time. Okay, what is dotted grammar rule means? It indicates the state of parsing process at any given time. Okay, for example, every dotted rule falls in any of the three categories. One is, there is a dot here, and after that there is a symbol, which means initial prediction. Okay, initial prediction. I'll stop after covering this topic only. Okay, partial parse. What is meant by partial parse? Dot will come here and there are two symbols. Okay, this is called partial parse. What is completed parse? So dot will come all after the variable. Okay, this is called completed parse. There are three types of grammar rules. We can define based on the position of dot. We can define three type of grammar rules. Okay, okay. This is about next we want to discuss this algorithm. This is the pseudocode or algorithm for early parsing. We can discuss this and example in the next class. Okay, okay, okay. Because of net connection issues, I started late. Okay, okay. Thank you. Please give your attendance in the chat box, then you can leave. Okay, okay. Thank you.